Okay, then we're back, ready to start. So now we're going to create two lines. So we're going to create this line, which is going to be tangential with the circle, and also the other vertical line that also needs to be tangential with the circle. So we'll start off with the angled one. So we'll attach it to the edge of our baseline to begin with, and then we'll pull it up to our circle. And actually, if we are lucky, and especially if you zoom in a bit so that it's a bit easier to see, you can actually get Inventor to automatically lock it in as a tangent there. So you see, I just moved it a little bit more up, and then I got the tangent symbol up here, which is just a circle and a straight line. So I just connected there, and I got it directly. Nei, det er ingen forelesning neste uke. Da er jeg på Stord. Det er derfor. Det er ikke bare 4 timer heller, det er 6. Jeg begynte klokka 8 i dag. Med undervannsteknologi. Now we'll do the next line, which will be going up here, vertically. And that one also connects to the tangent there. And then we've gotten the outline, so now we can trim away what's unnecessary on our circle. So then we'll just exit our line option, and we'll start by choosing the trim option up in the modify section. And here we'll have to do it several times, because Inventor just trims what's between two other intersecting lines. So the first part here will be trimming this one, then we have to trim this part, and then we have to trim that part. So it will be a 3-step operation. So then we only got the arc left after we've removed those 3 parts of the circle. Then we can finish our sketch. Zoom a little bit out here so we can see it. And then we can extrude it. And just to show a point here, if you want the center of your part now to be placed along one of the center planes in the coordinate system, then you choose, instead of direction 1 or direction 2, you choose the one that is symmetric. Because then when it's extruding it to the same length on both sides, instead of just doing one direction. And that means that we will have one of the center planes going straight through our part. It's not necessary for this part at all, but if you need it, for an example, to do some mirroring operations and using that center plane as a reference for a mirroring operation, it's very nice to just extrude symmetrically across a plane like that. So this one is supposed to be 35 millimeters thick, so 35. So then we have it. Now the only thing we're missing is the hole going through it. And we'll use the hole function. And luckily on this one we have the same center point for a hole as we have for the curved edge. So we'll use the hole function. We'll select the side of our part, but first we need to set the placement option to concentric. So the concentric placement option. And we'll choose the side here because we want the hole to go through this way. And then our concentric reference will be the curved edge. And then we can set the diameter of our hole, and it's supposed to be 24 millimeters in diameter. Then we'll click OK. And then we're already done with this part. So it's a really quick one to model. We need to set the material before we save it. So we'll go down and put it to stainless steel. Since we're going to create this one next, the assembly where we're going to place weldment symbols, that it's going to be welded together, it is very important that all three parts are the same material, or else it's going to be very difficult to do any welding. You can weld different materials together, but it requires quite a lot of expertise and certification of welders in order to be getting the correct standards for that weld. So then we save it, and this one I call the pad I itself. And that's a regular name for it, a pad I, because the whole point with this one is to bolt the base plates to another part, and then you're going to put a shackle through this hole, the large hole. So you're going to lift something with it, basically. And usually wherever you are going to lift, you're either calling it a pad I or a lifting lug or something like that. So this is a pad I. And then we'll start creating the drawing for this one. And once we're done doing the drawing, we'll start on our assembly. So then we have, we'll be getting more than a full hour on the assembly. So that's good. We get loads of time to do it properly. So we'll start a new one. We go to the iso.idw to finish this drawing. We click create. So then we place our base view, which is going to be automatically selected for the pad I, since that was the last part we were in. I need to flip it around a bit to get to see it from the side. And I also need to do a projected view to get the thickness of it. So exactly which way I'm projecting it doesn't really matter. I don't want hidden lines to be shown, so the hidden line removed option is the one I want up there. And we'll try to see how it looks in 2:1. That's a bit big, so I think we're just going to stay with 1:1. So 1:1 is a bit small, but 2:1 would have meant that we had little room to place our dimensions. So we sort of have to go with the lesser of two evils in this case. So we'll go to the annotate part of the toolbar. I will start off by placing center points, because we have a curved edge and we also have a hole, so we need to have center marks to show where the centers are. So both on the curved edge and on the hole. And then we can start placing dimensions. So the first dimension we'll place is from the corner here, and a horizontal dimension to the center mark, just to show the length there. And we have to remember to change the formatting to method 1B. Next, we'll just do the entire length of our baseline. Which will be 137. Then we can do the height up to the center point. There. And of course we're going to need the radius of the rounded edge. The R30. We also need to put in the thickness of our part. And we'll try to connect it to the 30 millimeters on the other side. Like this. So we'll get a nice nice line going between those two dimensions. Now there is only one dimension that's really missing, and that's the hole diameter. But one thing that could be nice to put in here as just a reference dimension is the approximate angle here. So we'll click on the baseline and then on the other line here. And you can see already the symbol shown beside my mouse pointer is of an angle. So Inventor, so long as two lines aren't parallel or at a 90-degree angle to each other, Inventor automatically chooses to show the dimension as an angle. And what we'll do in this case is we'll place it in here. We're going to put reference on it, because this is just a way for whoever's machining it to have some sort of control point on the angle. And then we're also going to change the units of it. So we're going to switch it to just show no decimal points on it. So if we click OK now, we can see that it's now switched to just showing 30 degrees. It was 30.20 something. But now it just shows 30 degrees, which means that whoever is manufacturing this part, when he's going to measure it, is probably not going to be able to measure point something degrees. He's only going to be able to see that it's somewhere between 30 and 31, but fairly much closer to 30. So that's a good way of just letting them have a way of controlling what they've created. Also, I'm just going to pull the dimension a little bit to the outside so that it's not inside my part here. And then it wanted to show it, let's see here. Yeah, then we have to use that one. So after you pulled it to the outside, now it's suddenly switched around with the angle here. We really don't want that, so we're going to right-click it, go to the options, and we're going to remove the mark on use quadrant. Because then it should be, we have to do that before we move it actually. So use quadrant, we have to put that one back, either that or just do the undo button until you get the dimension inside again. Then we have to remove the option of use quadrant before we start moving the dimension itself. Because then we get the dimension on the outside and we have the arrows in there. Another thing that could be nice to do here is to actually switch the arrows so that we get the arrows on the outside instead of on the inside of the angle. So then we right click again, we go down to options, and here you can see we have an option that's named arrowheads inside. So if we remove the mark on that one, it has now switched the arrowheads to be on the outside. It looks a bit better with regards to getting as little as possible of our dimension lines inside the part. Just give everyone a chance to finish that. Looks like everyone is with me. So I'm going to now place the hole dimension with the hole and thread function. We need to switch it to method 1B. And in this case, we only have one hole, so we don't need to add any quantity notes or anything. So then we just need all of our notes and fix the title of it. So I'll just start off putting those in. General tolerances. And surface finish. Whoop. ISO 2768-1. Still using medium. ISO 2768-2. Capital K. Then I'll also put in the break sharp edges note right away. 0.2 millimeters by 45 degrees. Then I'll just move my notes into more appropriate locations. Then I need to place in the surface finish symbol. I still want the manufacturer to remove material when they're creating this one. And I'm putting in RA 6.3 as the surface finish. Then we need to get the parts list in here to get the correct material. Select the parts list and then one of the views. Place the parts list. And then I'll double click it. I'll change the layout and remove the title. And then I'll go into the column chooser and choose the material column and remove the other ones. Then I'll just expand it a bit and place it in the corner. Just let everyone catch up before we do the title box and save. Winkeln, yeah. So many of you haven't been able to move the angle yet, so I'll just show that once more before we continue. So what I'm going to do is to just remove my angle completely, and I will do it from scratch. So in order to place the angle, I select the dimension function and method 1b. Then I'm going to select the two lines, and since they're at an angle to each other, Inventor automatically chooses the angle option. You can even see it beside your mouse pointer before you click on the line. And then we're going to place it in here first. And first of all, this is just going to be a way for whoever is machining it to just quickly check that it is approximately on the right track with regards to the angle. So we're going to put it in as a reference with the parenthesis around it. And we're also going to change the units so that we don't get any decimal points in it. So we're going to remove all decimal points, then it just shows up as 30, because since it's not a requirement to have this measurement at exactly 30.26 degrees, it's no point in actually showing that much detail to it. So 30 degrees is more than enough to just check that you're more or less there when you're creating it. It is the length of 137 and the radius up top that decides exactly what the angle is going to be. So we click OK there. Then before I move the dimension to the outside, I need to exit the dimension function up top there. Then I click on my angular dimension just to mark it, and then I right click to get this menu open, and there we have the options menu. So we can go down to the options menu there, and we want to remove the option of using quadrant, or else it's going to change it to 150 degrees instead. So we're going to remove the marking on use quadrant, and then I can pull the dimension to the outside, because it's still going to show it as the dimension between these two lines. then for now my arrows on the dimension line of the angle are shown on the inside. So I can go back to the options menu and I can choose to show the arrows on the outside instead. So I mark it once more, right click, get back to the options menu, and here we have the option of arrowheads inside, and we can remove that option, and then we get the arrowheads on the outside instead. So then we can start filling in the title block. We go over to the ISO part on the browser tree. Oops, need to open it up, and then we edit the field text. We've got this property field open, so we open the I properties also, and we start going through the tabs and filling in the information we need. So the title for this one was Pad I, student number as author, company name, part number will also be Pad I, and revision number needs to be in there, and we need to put in the checker and the approver, and also the date of approval. Then we click OK, and we just check over all the lines to see that we've gotten all of the information in place. And we click OK. So then we're finished with this drawing also. So I'll just give everyone a chance to catch up a bit before we start creating the assembly itself. So now I'll just save the drawing. And then we can get ready to start the assembly itself. So in order to start the assembly, we go up to the new button up top, the blank sheet there, and we click it. And the one we're supposed to use now is the standard.iam. So this one, and we want it in millimeters. And then you can see some of the other ones that you can choose here are actually called Weldments. And those are a bit more special because you can still do the same assembly as you do in the standard one, but you can also add welds, so you're actually adding 3D welds onto your parts. It's a bit more advanced than what we're going to get into in this course, but it's a nice way of getting your 3D models to look perfect, just like they're supposed to look in real life once they're finished. But in our case, we're just going to use a regular assembly, put the parts together, and we're just going to add manually the welding information in the drawing. So the standard.iam in millimeters, click on that one, and then we come in here. So it's still looking the exact same as when you're in for parts. You still have the same background, you have the browser tree, but now you can see up top you have some different toolbars instead. So what we're going to do now is we're going to place in these 3 parts that we have just created. We're going to place them in here, and then we are going to make them stick to each other, basically, in the way they're going to look like. So in order to place them, we need to go up to the corner here, and we're not going to place from the content center, because we're going to use place from content center in the next practice task, because in the content center you can get many standardized parts, so different dimensions of bolts, nuts, anything like that, sealing solutions, so O-rings, stuff like that. You can find it directly in the content center, so that you don't have to sit down and actually create 3D models of absolutely everything that you're going to use. If it's a standardized product that you're going to use, you'll find it in the content center usually. So so long as it is, for an example, a bolt, and it has an ISO standard or a DIN standard or something else like that, you're probably going to find it in the content center. So it's a lot easier way of just picking them and placing them instead of creating them from the bottom. So what we're going to do now is to open the drop-down menu here, and we're just going to use the place option. And once we click the place option, we get to see the 3 part files that we've created inside this project. So here is the point where we like to use the projects, because once we get several parts in one project, it is very nice to have them gathered in the same location within the project, because then you're going to find everything you need when you're creating assemblies. So we can start off with let us start off with the small base, maybe, the first part that we created. Then we'll click open. And first off now, it's just following our mouse pointer around, because we don't really have, we haven't told it to be placed in any location. I'm just going to flip my view a little bit around here to make it easier for you to see. So I've got the part here, it's semi-translucent, and it's following my mouse pointer around. Since this is the first part I'm placing, I don't want to just click somewhere and place it there. I'm going to click my right mouse button to get this menu up. And what I want to do is I want to place it grounded at origin. And origin, that's the origo point of my coordinate system. And the fact that it says grounded means that it's going to lock it into place there. So it's going to lock this part to the center of my coordinate system if I choose place grounded at origin. So now I put it in there. I only need one of these because I'm not going to create several of the assemblies. So then I just click cancel. Right click it and cancel, or use the escape button. I'm going to flip my view a little bit around to get to see it from a better point of view here. And the nice part now is that this one is locked into place. I can't move it anymore because it's grounded. So it's going to stay there. And the way you can see if you have a grounded part is to go over in your browser window and just look at the icon with it. You can see you have a thumbtack on the icon, and that means that it's grounded. So this one is locked into place. If I mark it blue like this, I can't move it around or anything if I try to drag it. So it's completely stuck there. And it's always nice to have at least one part that is grounded when you're doing an assembly, or else your parts are going to jump all around the place when you're starting to attach them to each other. So so long as you have your main part grounded, then all of the other parts are going to jump to this main part as you are attaching them. So now we need to place, I think we'll do this plate, so the large base first, or secondly. So we do the place function again, and then we choose the base large file. I'm just going to click open. And in this case, it doesn't really matter where I put it, so I'm just going to zoom a little bit out, and I'm going to place it over here. So if I then click escape, or cancel there, what we can now see is, if I mark the large base now, I can start dragging it all around here. So I can move this one, but I can't move the one that is grounded. So it is locked into place. Now what we need to do is, in order to achieve this result as we go along, we're going to first off attach these two to each other in the correct distance. So I need to find my dimensions here. Let's see. So what we're going to do is we're going to make sure that certain parts, certain of the surfaces of our parts are going to be connected to each other. So the first thing we're going to do is we have the grounded one, and we're going to make sure that the top or the bottom of these two are going to be aligned. So they're going to be on the same plane. So that if we push them all the way together, they're going to be on the single line there. And the way we're going to do this is to use the function up here that's named Constrain. And the first thing we can choose here is different assembly types. And we have what's called a mate, which is basically just putting two surfaces together, where you can also have an offset. So you can say, what we are going to do a little bit later is we're going to place this edge onto that edge, so that they're going to be all the way into each other. And then we're going to create an offset. We're going to say that you have to be this many millimeters apart. And then they're going to be locked into place there. So we're going to use the mate quite a lot here. Other possibilities you have is to lock things at an angle. If we had placed them together like this, we could have set it at, for an example, a 45-degree angle. So it would have ended up something like this. You also have the possibility of setting it tangent. So then we could make this edge tangent to the rounded edge there, so that it would place it onto it like this. You also have the possibility of using insert, and that is if you have a cylindrical piece that is going to be inserted into a cylindrical hole. So basically a bolt or a shaft or something that's going into a hole. It's nice to use the insert function. And you also have the possibility of locking them into symmetrical. So if you have many parts and you have some of them are equal parts, you can lock them into symmetry. You also have several tabs up here, so there are more things that are possible to do. In this course we are mainly going to stay in the assembly part, but I'm just going to quickly show you other options. We have in the motion part, you can lock two parts together, but they are able to move a little bit with regards to each other. The same with transitional. For an example, we can say that this edge is going to be connected to this edge of the part, but it is translational, so you can basically just move it around like this if you want to. So it can wander along the edge there. And you can also set a coordinate system constraints if you want to. So basically giving exact coordinates of locations. But we're going to stay in the assembly parts for this course. The more motion parts and stuff like that, it's more useful if you have really complex assemblies where you have lots of moving parts and you really want to see that parts are not going to collide with each other once you're using them. For example, if you have some levers and you have some rotating parts and stuff, and you think that maybe some of them can collide with each other, then you can use different transitional and motion stuff so that you can move them back and forth in the planned area where they're supposed to move, and then you can actually see if something is going to collide. For now, we're going to use the mate function, which is the first one. And then we have a couple of selections to do on the side there. So we have 1 and 2, which basically means that there are 2 surfaces that we are going to select. And to begin with, we'll select the top of our grounded piece. So you can see it turns bright blue once you select it. And for the second one, we'll select the top of the large base there. And what it did now, as you can hear, you even get a sound clip to tell you that they've actually been connected. So that's a nice one to actually have on when you're working, because then you can hear what's going on, that you've actually connected them. Because if you click on an assembly and you don't hear that sound clip, then there's something wrong. Inventor is not able to place that constraint on it. So what it's done now is that it's flipped it. So instead of putting them on the same line here, it's flipped it and placed it on top there. But then we have these 2 options where we can switch around. And you can actually see the option that is marked in blue there. It says that they are going to be placed onto each other like that. So if we switch the option there, now it's rotated it back around and put it on the same level there. It doesn't matter that they're actually colliding right now. We're going to fix that later on, because we can still drag it around. But now they are locked into the same plane. So we can't move the large base up or down. We can only move it in the X and Y directions. No, the X and Z directions in our coordinate system here. So the Y direction has been locked now, so we can't move it. So then we click Apply. Then it's possible to place another constraint. But for now, we're just going to drag it a little bit away to make it a bit more visible, what we're going to do here. We're going to do the exact same again, but now we're going to get this edge to get stuck onto this edge. So we'll go into the constrain part again. We'll still use the same mate type, the first one here. And we'll select this edge on the large base. And now we need to flip around a little bit so that we can see this side of our base, of our small base. So I flip my view a little bit here, because I want it to be connected to this part. So I'm going to click there. And what it's done now is just to set them directly onto each other. And that's fair enough. But according to our drawing, we're going to have them at 24.3 millimeters apart. So what we need to do now is to look at the offset option here. So we need to add an offset. So we put in 24.3. And then you can see that it's physically moved them apart. But they're still locked at that distance from each other. So now the first thing we did with the first mate, we locked the Y direction so that they couldn't move in the Y direction. Now we have locked the Z direction, so we can't move anyway in the Z direction. So the last one we're going to put in is to lock it in the X direction, so that we can't move it that way either. So we press apply here. But in order to manage to lock it in the X direction, we're going to need to use some of the planes that we have in here. So what we need to do is to go into the browser tree here. We need to open up the small base first. And we need to look at the origin folder for it. And here we can see that we have the planes that we had when we were creating the 3D model itself. We can see the different planes when we are marking them here. And then we do the same for the large base. Here we can also see the different planes. And in order to lock these two together in the X direction, if we use the XY plane on the large base, and we use the YZ plane in this case, it might be different planes in your parts. It depends a bit on how you placed your sketches and stuff when you created them. But just look at the drawing. So if the plane that's going through the middle here and the plane that's going through the middle of the other part. That is so long as you have centered your sketches when we created them. So then you will have these planes in the correct positions. If you don't have them, we're going to have to make some adjustments in how we place it. So now I have one plane there and one plane there, which I can place together. So I'm going to go to the constraint option again, still using the first one, the mate. The one there that's named mate. And now I can choose the YZ plane on the small base, and you can see it turns blue there. And then I can go down to the XY plane on my large base and click that one. And then they are moved into the same line. So now they are locked into place. If for some reason your plane is not in the center, it's out here or something, that you didn't center it correctly in the original sketch, that's not a huge problem. All you need to do is to add an offset instead. So I think I'll stop the lecture there for now, so that you get the break also to look at it, and then we'll make sure that everyone is in the same location before we begin after the break. Right, then we're back. I'll just apply this one. Didn't actually press apply before we went to break. So now we've gotten these two parts into place, and we need to now add this part, the pad eye. So then we'll go up to the place function again, and we'll choose the pad eye file, and we'll place it in. Just place it in a random location. We're going to constrain it into the appropriate location afterwards anyway. And then we just exit it. We don't need to place several of it. That is a possibility. If you are going to put in 2 or 3 of a part, then you can just put all of them in at once if you want to. So for this one, we're going to constrain. We need to look at the underside on it, because we want this surface, so that surface of the part of the pad eye. We're going to constrain it to the top of the part. So we'll choose the underside of the pad eye there. Then we'll switch back our view up top here. And now it doesn't really matter which one of these we choose, because they're on a plane anyway. So no matter which we choose, they're going to be connected to each other. So we click on there. So we got it into place. And that means that we've locked it in the Y direction. So it can't move up or down now. So now it's locked there. But we also need to lock it in the X and Z directions. And for the Z direction, it is fairly easy. We just need the front of the pad eye to be on a line with the front of the small base. So we'll just mark the front there, and then we'll mark the front underneath there. But now we need to think a little bit about it, because we're setting those up like this, but with the solution option that's on there, it's going to flip it, because it wants this part and this part to be facing each other. So it wants to flip it around like that. So if we instead choose that one, then we're telling them to face the same direction. So then both of them are going to face that way. So now I can click that one, and it snaps into place right away. So then we have that one. I'm just going to press apply there. And now we need to lock it into place sideways. I'll just wait a little bit. I can see there's a couple of people that need help, so. Right, the last constraint that we're going to put into place is going to lock the pad eye sideways here. So we're going to lock it in place so that we can't move it sideways. And since I chose, when I extruded mine, I chose to extrude it symmetrically across the one of the planes. I could just align my plane that I have here. Let's see, I'll just show it here. So I got one plane going straight through my pad eye, so I can align that to the plane I've got going straight through the small base. If you did only extrude it in one direction, you might just as well use a constraint on just the side of the pad eye, and then you just use an offset to get it into place. It's 35 millimeters thick, so you just do 35 divided by 2, and then you're going to get it in the correct position. So I'm going to do that just to show you how to fix it. So I'll choose just the side of the pad eye there, and then I'll go up to the small base in the tree here, and I'll find the plane that's going through the middle of the small base, and I'll click on this one. And since I've locked this one into place, it can't rotate or anything, I have to use the flush option. So there. But now I've got it over on the side, and I want to get it in the middle. So what I do then is to use the offset function. And first off, I'll just write in 35, because I want to see which way it moved. Now it went that way. So if I want to have it move the other way, I'll just do negative instead. And I don't want it to move all that way, so I'm going to divide it by 2. And then I've got it exactly in the middle. So then I click apply. And then everything on my assembly here is locked into place. So I can't click and drag on any of the parts. All of them are stuck together. So then we're going to save the parts, or save the assembly, rather. And once we click save here, we can see we have a new kind of file, a .iam file. So we can't see any of the others in here, because it has to save it as a .iam file. So I'll click save on this one. And now I actually named it assembly1. That wasn't so smart of me, but I'll fix that when we get a bit later on. Actually, I'm just going to do a save as and get it in a proper name. And to give it a proper name, I'm going to give it still pad eye. It's the same name as we put on this one, but I'm going to add an abbreviation behind it. ASSY. That is a short for assembly. So many companies use that. Some companies hate using it. They don't want abbreviations like that in their part names, but other companies love them, so they use abbreviations everywhere. So it's not always that easy to know what's being used where. So we'll save it like this. So now it says up there, it says pad eye ASSI. And then we can start the drawing, because now we need to figure out how are we going to put the welding information into place in our drawing. So we managed to place all of our parts together so that they look like this, and they are all stuck to each other. But we also need to tell whoever is going to create it what they're going to be welding on it. So we create a new one, and even though we are going to create a drawing for the assembly, we're still going to use the iso.idw. So the drawing file doesn't change, even though we are doing it for an assembly instead of a part. So iso.idw and create. And when I now click on base view, it automatically selects the assembly, since that was the last one we looked at. It might be nice to put the base view as looking at it from the top, so that we're looking straight down on it. So I'm going to flip it a bit around here, looking at it from the top, and maybe just flip it 90 degrees also. And it would be nice to have at least one projected view, so over on the side there. That was a bit quick of me. I should have changed the scale. We'll try 1:1 scale here. I doubt we can do 2:1. That's going to be way too big. So a 1:1 scale should be possible. Let's see. Yeah, we just need to move them a little bit so that they're not crashing into each other. Then I'm going to add another projected view because I want to flip this view. I want to look at it, instead of just looking at it this way, I want to also look at it from this angle. So I'm going to create a projected view and place it over on the side here. So I'm going to create that one. The nice thing is now that since this is an assembly, it is very nice to have one of these isometric views where we are looking at it at an angle from here. But since we have placed this one that we're going to put dimensions on, we can easily create an isometric view from that one that's going to look fine. So I select this, the last view I created, and I want to create another projected view from that one. And I put it over on the side there, and then I'm going to get it looking like this. So it's going to, it gives you a very good idea of how it's going to look after you've welded it. So I create this one, but I don't want that view to be that big. So I'm going to change the scale of it by double-clicking on it and getting the scale down to 1:2, so halving the size of it. And I also want to put shade on it, just to get it to show better. So I'm going to put shaded on there, and click OK. And then I'm going to move it over to the side here. So then we have whoever is going to weld these parts together, they're going to have an easy job of seeing how the finished product is supposed to look. And now we need to start adding information to the welder. What's the dimensions and everything, and how are the welds going to look? So the most important thing that our welder needs to know is the gap between the bases. So he needs to know the dimension that we put in there, the 24.3 millimeters. That's a must to put in, because we don't. It's going to be difficult to put the distance from where the slope begins here and to the end. That's going to be a very difficult one. So it's much easier to just give the gap between the plates. So we'll switch over to the annotate part of the toolbar. And we'll do regular dimension. And we'll set it between these two lines. That's going to give us the gap that is needed. And we need to put it to method 1B. And put it in place there. Because that's a distance that the welder that's going to weld this together, he actually has to measure this out and make sure that it stays 24.3 while he's welding it. So that's a very important measurement in this case. It would also be nice to put a symmetry line on this view, just to show that it's going to be centered. So the pad eye part has to be centered on the large base, and it also is going to be centered on the small base. So we do a center line, and we run it from one end and to the other. We create it there, which means also that we can put a symmetry line on this one. So from top to bottom. So now we can start placing a welding symbol in here to tell where it's going to be welded. And most likely in this case, we're going to have welds going along the side here and also along the side there, and on both sides of the pad eye. So the pad eye is basically going to be welded on the sides and to the plates. And we can do that by placing a welding symbol on this view here. So we go to the welding symbol beside the surface finish symbol there. We click on it. And we're going to place it in the corner. So we're going to attach it to the green dot in the corner there. And we're just going to drag it a bit up so that we get some room to add the information that we're going to place in there. And once we place it, we have to right click and do continue, because you can continue placing these lead lines, so that if it's very tight space in here, you can't really put your symbol in here. You can put your lead line with several angles going out to another spot. But we don't need that. We got plenty of room, so we're going to just click continue there, and it's going to place it here. So now we need to add a lot of welding information in this window. The first thing that we need to know when we're going to place welding information is that we need to know the thickness of the weld. And the thickness of the weld is basically from let's see, I'm going to pull this one up a bit. When we have a 90-degree corner and we're going to weld inside the corner here, the thickness that we're going to put on the weld is this dimension. So it's from inside the corner, and it's going to go out to the outer edge of the weld, and it's going to go out hit the outer edge at a 90-degree angle. So it's called the A measurement of the weld. This is something that Torbjørn is going to go more into detail with you when you start calculating welds, because that's the thickness of the weld that we use when we are calculating it. But that's just basically to get you to understand why we are going to write an A in here. And in this case, we're going to use a 3 millimeter thickness. So in the next one, we put in a 3, which means that the thickness of our weld is going to be A3. We also want it to be welded on both sides, so we can add another symbol on the other side of the weld line here. So we can do weld symbol here, and we want another fillet weld, as these are called. And this one is also going to be A3. So we want symmetry here. We want equal sizes on both sides with the welds. Now, just to get to teach you a bit about how the weld symbol look, we are now pointing at this corner here, and that means that in our weld symbol, the part that is placed onto the continuous line up top there, so our top part of our symbol, that's going to be on this side. But on the dashed line, which we have underneath there, that's going to be on the other side of the material. So that's why we can put two symbols on each side of the line here, and because we are telling basically that you're going to weld on both sides of the material. So you're going to put it in there. And then it's the difference between having a continuous line and a dashed line that is telling us which side you are on. Which isn't really important in this case, since we're using the same dimension on both sides for the weld, so it doesn't really matter which is which. But in another case where we might have A5 on the opposite side, then it would really matter, because then we had different thicknesses for our welds on different sides. So in this case, we don't really need more than that, because that's going to be our welds along these edges. But if you have a circular object, for an example, and you want the weld to go all the way around, you could add a symbol here, where you could put in a circle, which would mean that you would run your weld all the way around the piece. So that if you have the end of a pipe that you're welding onto a plate, for an example, you would use a circular weld, because then you would weld all the way around the pipe. So we're not going to use this in this case. That's just to show that that's an option. You can also put in on this side of the triangle symbol, you can put in lengths and amounts of welds. So basically, if you have a 5 meter long area where you're going to weld, you won't necessarily have to weld for 5 meters in a row. That's going to make a way stronger weld than what you necessarily need. So you could calculate exactly how long of a length of weld you're going to need to get the necessary strength, and you can put it in as, for an example, divided into 4 pieces that are going to be 40 millimeters long. So then you could put in 4 and 40 millimeters. So then you would know that you would space out across this total length where you're going to weld. You're going to space out 4 different welds that are going to be 40 millimeters, instead of doing a continuous weld along the entire line, which would definitely be strong enough, but it will also take a lot more time than just doing sections of welds along it. So then we've got the welding symbol in on this drawing. We can exit that one. And one more thing that is nice to put in for an assembly drawing like this is to just get the largest of the external dimensions of the part. So we want to put in the total length of the part. I need it to be method 1B. Let's see. So we'll do a dimension, and we have to remember to switch the format to method 1B. We can do the total length of the part. We can also do the total width of the part. And we can do the total height of the part. The reason that we are putting in these total dimensions is basically to give whoever is running the logistics department in your company a chance to be able to figure out how much room is this going to take when we're going to transport it, basically, or if we are going to create some packaging for it, a small crate or something like that, then you know more or less the internal dimensions of what you need in order to package it. So it's just a nice extra information to add there. It is also usual to put in center marks for holes. Here we don't necessarily need to place a center mark on curved edges because we're not going to manufacture this part. It's already been manufactured, so the fact that this curved surface shares the center point with the hole, that doesn't really matter in this case. So we're just going to put them on the holes. And the main reason for using center marks on holes is just to show that there is a hole here. So here we have a cylindrical feature going through the part. So then we need to place a parts list, and this time we're definitely not going to remove the title because we're going to have several parts in it, so we need to know that this is a parts list. So we go up to parts list, We select one of our views and we click OK. And then you get this thing up. And what it's saying is that the BOM view is disabled in the referenced assembly. So what it means is BOM is short for Bill of Materials, which is what your purchaser wants when he's going to purchase the raw materials for creating something. So you want to enable the BOM view because it's something that you need in order to create this assembly drawing. Then we place the parts list down in the corner here. And we've got the name through the part number of each of the parts. We've got item numbers and we've got the quantities of each of them. We don't really need the description in this case, which is blank. So we're going to do a little bit of editing to which columns we are watching. So we double click the parts list and we go into the column chooser. And we'll remove the description column. In this case, we don't need it. And instead, we could add the mass column, for an example, just to get to know how much mass each of the items have. I think I forgot to press add here. So mass and add. So then we get mass beside the part number, and we click OK. Just to get it to look a bit better, we can just click and drag to get the parts list to be the same width as the title box. So there approximately. So now we've got item numbers, we have quantities, the names of the parts, and we also know how much they weigh. Then we have something that's still missing here, because I've been talking about item numbers here. And the item numbers are to identify the parts in our drawing. And in order to identify those, we need to place something which is just called balloons, basically. So we go up to the corner there, where we see the balloon symbol. And there are a couple of ways of doing this. We can either use the first option, which is manually placing balloons, which is fair enough in this case, so I'm just going to show how it works. Then I'm going to click on each of the individual parts in the assembly, and it's going to get a balloon. And the balloon has a number inside it, and the number corresponds to the item number in the parts list. So this is just to make it a bit easier to orient yourself inside the assembly drawing. In this case, it's not really difficult to orient yourself, but when you're starting to get 50, 60, 70 parts in one drawing, then you really need to have those balloons in place. One other way of placing balloons is to use the drop-down menu there. And then you can use the auto balloon options. So if we click on that one, we can select a view, like this one. And then it says add or remove components. So then we can just mark several components here. We're not going to ignore, I need to remove the first balloons I placed, or else the auto one is not going to work. So I select the view, and I can click on the parts. You can also create a selection box by dragging and dropping across it and marking everything. Then I can use select placement, and I would like to have them placed around my view. And then I can move my mouse out here, and we can see I can choose a little bit where to put them. Afterwards, I can manually move each of the balloons. So I'm just going to place them somewhere like that, and click apply. And then we can see that I can move the arrows a little bit to get them to show a bit better here. And also for this one, maybe I could actually keep this one over here and move the balloon instead. So using the auto one wasn't really quicker in this case, because we only had 3 parts. So just placing them manually was the quickest option with 3 parts. But again, if you have a parts list with 50, 60, 70 parts, using the auto option is very nice. Then you get all of them placed, you're not forgetting any one of them, and then you can just arrange them afterwards. One thing that you can do to make sure that you have everything you need of the balloons is to just double click on your parts list afterwards, and then you can see over on the side here that there's a small balloon on each of those. So that's going to tell you if one of your parts is missing the balloon inside the drawing, it's going to also miss the balloon inside the parts list there. So that tells you if you've missed one of them. So we won't get a chance to finish this one. We are already over time here, and you've got Torbjörn also. So the thing that we're missing here is to add a note with the general welding tolerances. But that's basically the same style as we're doing with the general tolerances and surface finish on regular parts. And of course we need to fill in the title box. So I think we'll stop there, and I doubt we'll actually finish off this drawing next time. We'll start on practice task 8 instead.